A long time ago, in a galaxy far, far away, Erin and Pam agree to battle over what will determine their grade on the AP Calculus exam. While Erin, the majestic destroyer of math, strives to achieve, if not exceed, 5, Pam, the conqueror of nap times, struggles to pass.
It appears there's an obstacle in the way. Let's see how they do. Ooh, this is looking rough for Pam. Let's see how Pam is doing compared to Erin so far. The graphs displayed above represent Erin and Pam's leaps. Erin's leap is obviously majestically smooth, while Pam's is staggered, and you can tell that she tripped somewhere in there. The graph tells us where the curves intersect, so we already know where the boundaries of our integration problem are going to be. We then take the integral of the function created when we subtract the higher curve from the lower curve. If we take the integral from about negative 3.07 to 1.26 of Erin's curve minus Pam's curve, we can see that the difference is about 1 foot. Ooh, better luck next time, Pam. Now let's get back to the race. Looks like they're neck and neck. Oh, what is this? Pam illegally pushed Erin, and she stopped. What does she see? It seems as if it could be a plane. Her amazing ability to guess distance accurately without any measuring tool, she estimates that the airplane is traveling at a constant 39,000 feet above the ground. Pam then uses her handy-dandy stopwatch to come to the conclusion that the airplane is traveling 880 feet per second. What distance is the airplane away from Pam at time t equals 10 seconds? At what rate is the distance between Pam and the airplane changing? Since we are given that at time t equals 10 seconds, the airplane is traveling at 880 feet per second, we can use the equation v equals d over t to find the distance. We can calculate the distance between Pam and the airplane using Pythagorean theorem. We can plug 39,000 feet into A and 8,800 feet into B to find C to be 39,980.49524 feet. Using what we found, we can calculate the rate at which the distance is changing. Let's see how Erin is doing. Wow! Look at her go! It appears Pam has decided to take a break from her brisk walking. Wow, how convenient! She finds some binoculars to people watch? Pam notices that 172 people have entered the park since its opening, but first we must find the integral of dy over dt to equal ky.
3 hours later.
After 3 hours of avid people watching, Pam counts 239 people in the park. We can now use this number to calculate the rate of growth of the amount of people in the park. To see if it is worthwhile for Pam to stay the extra 3.5 hours, we can use the initial amount of people that we already given and the rate at which the amount of people in the park seems to be growing. We can see that 1,247 people will be there. Pam decides to stay.
6.5 hours later.
Despite how interesting people watching has been, Pam decides to continue the race. As another way to throw Erin off, literally, Pam decides to push Erin off of a bridge into the water below. But, to avoid being sued for any serious injuries, Pam calculates the volume of this thin river that passes below the bridge to make sure that Erin does not hit herself at the bottom of the river. In order to find the volume of the river, Pam uses semicircular cross sections. She multiplies pi over 8 by the integral from 0 to 5 of two contours of the river. She finds that the volume is 68.755 feet cubed. Knowing the volume of the river, Pam feels completely comfortable pushing Erin off the bridge into the rapidly flowing river. Back to the race. Oh, and Pam scares her! Whoa, and there Erin goes, right into the water. It seems that Pam is throwing a paper ball at Erin to try and get her off of her game. Erin, who did the matrix in order to avoid the paper ball, still got slightly grazed by it. The graph above shows the curve made by Erin's body. What is the equation of the paper ball if it is tangent to Erin's curve at time t equals 1.5 seconds? We are already given the equation that represents the curve created by Erin's matrix move. First, we must find the y value at time t equals 1.5 seconds. We do this by plugging 1.5 in for t of the equation given. Now that we know the x and y values, the only thing we have left to calculate is the slope. To find the slope of the curve at t equals 1.5 seconds, we must first take the derivative of the equation given and then plug in 1.5 for t. Now that we have both the x and y values and the slope of the equation at t equals 1.5 seconds, we can use point-slope form to find the equation of the line tangent to the curve. Y equals 1.5x minus 0.875. Looks like we have a winner! Congratulations, Erin! Way to go! And here's Pam. Let's compare Erin and Pam's progress throughout the race, just to see how much more dedicated Erin was. Using the information given in the graph, what are Erin and Pam's velocities at time t equals 3 hours in miles per hour? Who is traveling the fastest? Since we are already given Erin and Pam's position functions, we can simply take the derivative of both equations and get their velocity functions. Then we just plug in 3 in for t and find that Erin is traveling at 12 miles per hour while Pam is running at 8 miles per hour. So Erin is traveling faster than Pam at time t equals 3 hours. Great job to both Pam and Erin.